Let's take this question from current electricity. And the question says, shown in the figure is a semicircular metallic strip that has thickness T and resistivity rho. Its inner radius is R1 and outer radius is R2. So let me just highlight the radiuses. So inner radius ये जो है, this one is the inner radius and this radius is given out to be how much? This is given out to be R1. And outer radius is given out to be, this is the outer radius which is given out to be how much? R2, right? Resistivity of the strip is rho. Okay. If a voltage V0 is applied between its two ends, so voltage को apply किया है, this is that voltage, right? So this is that external voltage. Let me just highlight it. This is that voltage and this voltage value जो आपको दे रखा है, that is how much? That is our V0. That is the source voltage. Okay. And a current I flows in the circuit, so definitely current I is also flowing in the circuit, and this is the flow of current which I have highlighted very easily. It is observed that a transverse voltage delta V develops between its inner and outer surfaces due to purely kinetic effects of moving electrons. Okay, so definitely it is very clear that if current is flowing in this direction, right, if current is flowing in this particular direction, as you can see that current is flowing in this direction, so definitely electrons का जो motion होगा that will be opposite to the flow of current. So this direction will be the direction of electrons का motion. Electrons इस direction में है, तो उसकी वजह से क्या है, एक ट्रांसवर्स वोल्टेज डेल्टा वी जो है वो डेवलप हो रहा है बिटवीन द इनर एंड आउटर सर्फेसेस. दैट इज ओनली बिकॉज ऑफ द moving electrons, means the kinetic energy or the kinetic effects of moving electrons, and there is no magnetic effect involved here. So there is an information which I have to highlight it, that we have to ignore all the magnetic field and magnetic effects that are being experienced here. So उनको हम ignore कर देंगे. Okay, so magnetic field is not considered. So it is a multiple correct type question, and the first part is we have to find the current, right? So current का value जो है, that current value is given out to be how much? That is equal to V naught T divided by pi into rho and natural log of R2 by R1. This is the value of current. So let's check कि ये current flow करता है या नहीं, ठीक है? Now what I have done is, for your convenience, I have drawn a three-dimensional view of this particular figure. ये जो नीचे मैंने strip बनाई है, this is the three-dimensional view in which I can highlight what? I can highlight the thickness of this particular strip also. ठीक है? So this is that particular thickness. As you can see that this is the thickness of the strip. This is that particular thickness. ये thickness आपको दे रखी है क्वेश्चन में, how much? This is thickness is T, right? And voltage is applied, so voltage is definitely your this particular voltage, that is our V naught, right? So how do you calculate this current that is flowing in this particular strip? इसमें जो current I flow हुआ है उसको कैसे calculate करेंगे? उस current को calculate करने के लिए सबसे पहले we have to calculate the equivalent resistance of the strip, ठीक है? Equivalent resistance calculate करेंगे. We have to calculate the net resistance. Okay, so now how to calculate the net resistance? What I can do is I can take a small length element of this particular strip somewhere here, ठीक है? So what I have done is मैंने इस strip का एक छोटा सा लेंथ एलिमेंट यहाँ पे मैंने हाईलाइट कर दिया है. दिस इज दैट वेरी स्मॉल लेंथ एलिमेंट विच आई हैव टेकन हियर, and this length element is having some width. So let's take the width of this element to be what? Width इसका ले लिया है dx, and center से जो distance है, इसका जो distance है from center, let's say that distance is x, right? Just keep this thing in mind that the inner radius is given out to be how much? Inner radius is r1, whereas the outer radius of the strip is how much? That is our r2. So ये strip मैंने cut कर दिया है, ये मैं यहाँ पे बना देता हूँ strip को, ठीक है? This is that particular strip I am drawing. This is not the whole metallic strip, that only the length element of that strip ये मैंने बना लिया है. इस strip का जो thickness है, ये जो thickness है, this thickness is given out to be how much? That is your dx, and this is the center, and this is the distance from the center is x, right? So let's calculate the small resistance now, right? So let's calculate the small resistance of the strip. Small resistance क्या होगा? That will be dr, ठीक है? Resistance formula we know that resistance is equal to what? Resistance is equal to rho L upon A, ठीक है? So resistance equal to rho L by A होता है, dr will be equal to rho, and length, what will be the length? Length will be, or what? Length will be pi into x, okay? And area will be your t, thickness into width, that is your dx, ठीक है? T dx will be what? T dx will be the particular area of this particular strip, right? So now when you calculate the equivalent resistance, so we can interpret that all these strips, ठीक है, ये जो strips मैं काटूंगा from R1 to R2, जब इन strips को काटा जाएगा, ये सारी strips को जोड़ूंगा, तो they will form a parallel combination. It is very easy to understand that it will form what? It will form a parallel combination. So parallel combination में जो equivalent resistance होता है, that is your 1 upon R equivalent, and that will be your integration of 1 upon dr. Limit will be from R1 to R2. Okay, this is how it is done. Okay, so let's solve somewhere here. This will be your 1 upon R equivalent will be equal to integration of R1 to R2, and this will be 1 upon dr. Dr value is how much? That is our rho pi x, and in the numerator it will be t into dx, right? So this is one particular case. Now just integrate it, very easy one. So 1 upon R equivalent will be equal to how much? Just take out the constant. Constant में आ जाएगा t upon rho into pi is constant. So R1 to R2 आप integrate करेंगे 1 upon x dx को, and this integration is very easy. So when you integrate this part, this comes out to be 1 upon R equivalent will be equal to t upon rho pi times natural log of x from R1 to R2. Just solve it. This will be t upon rho pi natural log of R2 divided by R1. This will be the 1 upon R equivalent का value है, and अगर मैं इसको यहाँ पे ही छोड़ दूँ तो let this be equation number 1. Let this be equation number what? Let this be equation number 1, right? So now the last part, that is we have to calculate the current, because first option में current बोला है. So current I will be equal to what? I will be equal to V naught upon R, right? V naught upon R equivalent, ठीक है, तो इसको मैं V naught into 1 upon R equivalent भी लिख सकता हूँ, ठीक है. Just for my convenience I am writing it as V naught into 1 upon R equivalent, और इन वैल्यूज को जस्ट सब्सटीट्यूट करना है. V naught is the external voltage, और 1 upon R equivalent का वैल्यू मैं कैलकुलेट करके आया हूँ. दिस इज दैट वैल्यू, दैट इज V naught T upon rho pi times natural log of what? R2 divided by R1, and this is the current which I am getting here, and I think it is matching also with option number 1. So basically option number 1 is also correct. That is current is equal to V naught T upon rho pi times natural log of what? Natural log of R2 by R1. So this option is correct, and this option is correct. So the remaining options B, C and D we'll discuss in the next video, and thank you very much.